Hi everybody, this is the third week of Calculus Mathematics course. First of all, I want to give an information about real numbers. That is, R, real numbers, is ordered. What's that? R is ordered. Here we can write real numbers, positive numbers, 0, and negative numbers. Here we have three sets. So we can give a definition for that one. We can give a definition. What's that? This definition. It is like that. Definition. Suppose or assume AB is R, or is in R maybe, or AB is an element of, is an element of R. That we say A is bigger than B, A is equal to B, or A is smaller than B. So if A minus B is positive and if A minus B is 0 and if A minus B is negative. These are the results of these things. If A minus B is 0, we get A is equal to B, and if A minus B is positive, this means A is bigger than B, and the other one like that, A is smaller than B. And we can give here this another way. Likewise, maybe we might say like that. Define again. A is bigger than and equal to B. What does it mean? This means A is bigger than B, or A is equal to B. And another definition maybe for mathematics is smaller and equal to B means A is smaller than B or A is equal to B. We define it's like that. Let's give an example by using these things. What are they? Let's write example. X is bigger than 4 means we have a real line here like that. Say 0 here and say 4 here. So in geometry, so we have 4 here, an empty 4, and we are going to find, maybe we can use here like that. We use here, and so answer is this place from here up to infinity. So this here is empty 4. It's okay. And next one is maybe another one. Yeah, another one is maybe like that. -1, smaller x is here, and smaller and equal 3 here. So this means x is bigger than -1, and simultaneously, this together, x is smaller than equal 3. So how can we write this one in geometry? Say 0 is here, and here is -1, and we have 3. Here x is smaller than equal to 3, so let's do it again with black. Here is full one, and we have no equal here, so we give empty here. So we have to find the solution like that. Yeah, this is the answer of this inequality. I have a warning here. What's that? Let's give an example for this one. X is smaller than -2, or x is bigger than and equal 5. This is a statement. So, you know, this means we have here real line, and we have -2 and 5 here. So we have to write this one and empty 2, -2, and this line up to -infinity, and this is equal, so this is a full 5 and goes to +infinity. But this cannot be collapsed. I mean, written as like that. Here writing some x or whatever, and this one. This is not be possible to write. This is nonsense. So let's open another page now. Now we continue with intervals. So intervals on the real line, Let's give a notation for this one. First, open ends. What does it mean? Where endpoints are not included. So use this bracket or this bracket from the left and from the right. And the other one, closed ends, where endpoints are included. Use this bracket from the left or this bracket from the right. And for the intervals, we have 9 types. We have 9 types. So let's write these 9 types of intervals. What are they? First one is open from the left and open from the right. B is open also. So we are going to write here open, and I have to write it again with black. Here open and open here. So A is here, B is here, and half open, and maybe also half closed, this one, half closed is here also. That is, from the left it's open and from the right it's closed, and the other one, from the left it's closed and from the right it is open. So we have to write in geometry, this one is open and this one is full one, closed. So we find like that, and this one is A and B here. So we have this interval, and you see A is closed, so here like that, and A, B. This is half open and half closed, and closed one is, two of them are closed, so A, B, on the left and on the right we have closed, so here like that, this one and this one, we have this interval and A, B, so we have all closed and full A and full B, okay? And the other ones, by the way, we can write, I also use it, but say it again, unbounded. What's unbounded? That is, we have a point and goes to infinity, and point here and goes to infinity. I use it, but I don't say anything about these things. So we have to write these things on plus infinity, and minus infinity means unbounded. So they are also real number, and we use like that. So the other types, by the way, we may also say, here, write it here, minus infinity and for plus infinity. They are not real numbers. Okay. They are not real numbers. I mean minus infinity and plus infinity. Next one. We have here A, comma, infinity. You see, we write opponent here. That is, infinity is not an element of real number. And here A and infinity again like that, and minus infinity B, here may be closed or open, but we have to write here, an opponent here. So how can we write these things here in geometry? Like that. A is full, so we have to find the solution like that here, from A to infinity, and here again another one. Now A is open, Here is A is open, and it goes to infinity again. It goes to infinity. Here, it starts with B. It starts with B, and B is closed. Yes, it's full. So it goes to minus infinity, and it's not closed. It's open. And again, this one, last one, it's starting with B, but B is open because here we have this bracket. So it goes to minus infinity. Again, minus infinity and plus infinity are not element of real numbers. So we use open brackets here. Yes, let's continue another page. Now let's rewrite maybe previous examples. Can now be written as we have this one. This means x is in for infinity. You know, here is open, and we have infinity open. And minus 1 x is equal to 3 means x is in open end minus 1 and 3 closed end. And we have the last one, x is smaller than minus 2 or x is bigger than or equal to 5 means x is in minus infinity and minus 2 is open end, or x is in 5 closed interval here, closed end here, and on the left, and we have infinity open end. This is the previous examples, so we rewrite it again. Now we have another subject now, also from real lines. Distance on the real line. What's that? Maybe distance from 0. Yeah, distance from 0. You may write from here like that, from 0 on the real line. Let's look for this one. This is real line again, 0. And let's say A here, and here is minus A. And you can describe here, and you may see that here is same as here. So these distances are equal. These are equal. So we can give a definition for this one. Definition like that. The distance from a real number x to 0 is called, you know this term, absolute value of x. Or you may say this one like that, absolute distance. And we denote it denoted by like that. This is the absolute value of x. So we denote it like. Let's give examples for this one, absolute value. Let's give examples. such as we have a real line here and 5 and 0 here. So you can see that this distance is denoted by 5, and you may see that it's 5 here. And another example is between -4 and 0. So you can see that this is a distance. So -4 in absolute value is equal to 4. Now let's look another example. So x is equal to also, this is the definition of absolute value. Here we can write here, if x is bigger than 0, this equals to x. And if x is equal to 0, this absolute value is equal to 0. And if x is smaller than 0, we write x and we put an minus sign in front of the x, so we can find the answer. You may remember from a previous example, it writes like that. So we have to put -4 here and put an minus sign here. So we find 4 like that, the distance of -4 and from 0. Yeah. So how can we define this one? How can we say this one? The absolute value of x or absolute distance, or here c, distance, and distance of x from 0. Yeah. Now let's look distance between 2 points on the real line. Now we have 2 points. So up to this point, up to this place, this way, and you see that we have only 1 point and 0. Now we have 2 points. Let's write it again. Distance between 2 points. 2 points on the real line. Let's say it's by an example. Here we have 2 point P and Q here, P and Q. So let's say 0 is here, and here is -3, and here is 5. So let's understand, let's find the distance here. You see it is 8. The distance is 8. Let's find it by absolute value, this absolute value. We have 2 ways to use this one, to understand this one. What are they? Let's notice it. Notice. And we have -3 and 5 here and 0 here. We are trying to find this distance. So first, maybe it is from -3 to 5, and the other one is from 5 to -3. We have to get the same result, so let's try. Here we have -8, so we know that is the definition of, from the definition of absolute value, it is -8, and if here is negative, we put a minus sign here and we get +8. So, and this one is 8, and you see here is positive, so it's same. So we saw that these are equal. So we can give a definition for this one now by using this. What's the definition? Definition is like that. Definition is like that. If we have 2 points A, B as the points P and Q, we are trying to find the distance of P and Q, between P and Q, is equal to B minus A in absolute value, or A minus B in absolute value. So this is the answer of distance between Q and P also. So this is a small example for this one. Distance minus 11, maybe 30, is equal to, you may see in absolute value, minus 11 minus 30, or 30 minus 11. So they are same. You may see it is minus 41, and here is 41. So they are all same as 41. Yeah, this is about distance part. Now let's try another subject. This is reals as decimals. Decimals mean base 10. So let's give an example from rational numbers. 3/4. Let's write here as a decimal number. You may find it by dividing 3/4, or we know that we can find this number by multiplying 25. So we get 75/100, and this equals also 750/1000, and this equals this one. By adding 0, nothing changes. So at the end we have here lots of 0 but nothing. This is repeating decimals. Have we got another thing such as non-repeating decimals? Let's try for irrational numbers. This is for rational numbers. So let's look irrationals. Example for irrationals. I think that this is non-repeating decimals. Let's solve this one and understand. And these are such as square root 2. You know that this is like that. I find it from calculator, and going like that. It changes. Nothing repeats. So it is non-repeating decimals. Also, we have number p. So it is 14, 15, 9, and it changes also. This is also non-repeating decimals. Yeah, repeating and non-repeating decimals are like that. And there's a warning and ambiguity for decimals. What is that? Let's write warning, and ambiguity of decimals. What's that? Such as 3, or point whatever, 9999 is equal to 4, and repeating zeros. Let's verify this one. Let's verify this one. And first of all, we are trying to find this x, 3.999. It goes to infinity. And then let's multiply with this x. So we find 39,999. It goes like that. And then subtract this, subtract x from this 10x. So we have here 9 like that, like that. Here we have 9x, and it goes. So we have 36 here, and you see that x is equal to 4. So we verified that. There's no ambiguity. So we find that 3.999 and goes to infinity is equal to 3.0000. It's okay. And this is the end of this week's lecture. We will continue with another subjects. See you next week.